In this video tutorial, we are going to build the JavaScript chart that you see on your screen. This is an area chart, but it renders a custom series renderer in the form of a crosshair with a tooltip that shows the numeric value for the current mouse position. We start the project from ground zero. We download the trial version of the chart library and extract the archive. There is a subfolder called Samples, and from there, we copy the Scripts subfolder. This directory contains all script files used by the chart component. We also need a web page and a JavaScript code behind file. So, we create two new empty files. Let's open the web page and add the code for an empty web page with a bit of CSS styling and references to some of the files in the scripts folder. We also add a reference to our custom JavaScript code behind file. Now we need to add a canvas element for the chart control to draw itself onto. We nest it inside a few div elements so we can give it the necessary size and position. We also give it an ID because we will reference it from the code behind file. Let's open the code behind file now. First, we add references to the namespaces we are going to use. Then, we need to create the area chart object. For that to happen, we use the area chart class. There are other chart classes available in the charting namespace. Most of them represent a specific type of chart. Some allow you to create custom type of chart on a standard biaxial plot. It's up to you to decide which one is best for your application. We declare a list with labels. Then we create a new connection of bar series. Regardless the name, the bar series class, which requires one list with numbers and one list with labels, is ideal to serve as data for our chart. We assign the newly created series list to the series property of the area chart object. If you are interested in the type of series which you can use, you can take a look at the members of the charting namespace. There are lots of series classes that take different number of data and label arrays. Before we test our sample, we need to call the draw method. And here is our chart. It doesn't look pretty, but the structure is correct. Let's style this chart. First, we assign a title to each series. We want them to refer to the last 3 years, so we use the standard JavaScript getFullDate method. The title of the series is rendered in the chart legend. We define now several brushes and colors for the grid. The members of the charting namespace list not only various series classes, but various style classes. These are classes for styling charts, and they take different arguments: pens, brushes, numeric values for the pen thickness of each series, etc. We will use the per series style class, which paints each series with a subsequent brush from the brush lists defined by this class. We can use the area opacity property to make the areas semi-transparent so that they don't overlap each other. A value of 0.7 looks good. As you can see, the legend automatically updates its colors to reflect the colors assigned to each series. Let's take a look at the theme class. Theme is exposed as a chart property as well, and defines the most appearance settings for each chart. We customize the legends and the font for the chart labels. We also changed the legend title. And our chart looks better and better. Time to do some grid customization. We want the chart to have a crossed grid, but we will paint the grid tiles and lines in very pale colors, so they don't interfere visually with the crosshair marker. The legend margin property allows us to place the legend anywhere within the chart. Time to deal with the crosshair. We handle the on-mouse move event of a DOM element. Let's use the event handler to print the mouse position to check if we get this right. Yes, everything looks fine so far. We create a new file for the new CrossHair renderer class. Note that we are not creating a custom type of series, but a custom type of series renderer. Renderers are the classes that draw various geometries based on the chart data. We have renderers that draw each data as a pie piece, a candlestick, a bar, etc. The crosshair renderer extends renderer 2D and defines a pale orange brush. It calls the constructor of the base class. You can get a better idea of the properties and methods of the renderer 2D class from the online documentation. Let's define a property mouse point. It will keep track of the current mouse position. We can create now an instance of the crosshair renderer class and assign its series property to the series of the area chart. We update the value of the mouse point property whenever the mouse move event is raised. We add the new renderer to the list of chart renderers for the area chart. As you see, the renderer 2D class exposes quite a lot of properties, which we can use in our class. We get the plot and axes variables from the context object, which comes as a parameter to the method. We calculate the position of the mouse in terms of chart measures, and we draw two crossing lines. As you can see now, the renderer calls the draw method every time the mouse position is changed. We can add now two helper methods that will convert the mouse coordinates into data values according to the intervals at the axes. We will show those values at the tooltip. We add the draw tooltip method, which uses the current mouse cursor coordinate and outlines a rectangle. In the method, we also draw text, the numeric coordinates of the current mouse position. Now we need to call the draw tooltip method with the mouse coordinates as calculated by the helper methods. And voila! Our tooltip is rendered along the chart crosshair. With that, our chart is ready. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.